till now we have been discussing about the shunt regulator, shunt linear DC-DC converter. Now we will discuss the other type, that is the series regulator. The series regulator is much more popular and then is useful for more higher powers. The structure is like this. I have an input, unregulated input Vi connected through a series element, and you have the output load. So this is Vi unregulated, this is V0, this is R0, and there is a series element Rs. Now the principle of operation is that we try to control the value of Rs, that is we regulate or we change Rs value based on the output feedback. So let us say we have a controller, and the job of the controller is to check a reference value. So let us say we have a reference value V0 reference, and checks also with the output V0, and then uses that to control the value of Rs. The idea is like this. If Rs value is increased, then the drop across that one will increase and the drop across this will decrease. If the Rs value is decreased, then the drop across that one will decrease and the drop across the output will increase. So in this way, by adjusting the value of Rs, we can bring about regulation in the output. So if you see the regulation action, it is something like this. We have V0. Now let us say for some reason, it may be due to Vi increasing or change in the R0. Let us say V0 increases for some reason. So if the potential here increases, then the potential at this point increases. V0 ref is a reference constant. Therefore, E has to decrease. So the error here will decrease, and if the error decreases, we would like to increase Rs such that the drop across Rs, VRS will increase. So once the drop across VRS increases, in this outer loop, applying Kirchhoff's law, as this increases, V0 will reduce. So if you look at the regulation action, because of an increase in V0, finally it has resulted in a decrease in V0, bringing it back to its original position by this regulation action. So in the practical circuit, we replace Rs with BJT, so that this change in the impedance is automatic. Now let me include the BJT, a semiconductor impedance, variable impedance, rather than fixed Rs. So I'm going to put a BJT there in place of Rs, and you have the load connected in this fashion. Now here I will try to put some kind of biasing circuit for biasing the BJT such that it operates automatically. Now at this point I will include V0 reference, and to include V0 reference I will use the shunt regulator. We are familiar now with the shunt regulator. See, this is the resistance and that is connected here. This blue portion is nothing but the shunt regulator, which will define the potential here, and that we can call it as V0 reference, related directly to the Zener voltage. Next, let us obtain the feedback from the output. I will use a potential divider, resistive divider, tap from the midpoint and then use it to drive this BJT here. So let us then include one more resistor here to give bias current for this BJT like this. So I will call that one as RB. I'll call this an RZ. I'll call this one as R1, R2, R0. This is Vi unregulated, V0 which we want to regulate. This is Q1 and this is Q2. So this is A V0. A is nothing but the step down or attenuation ratio, which is R2 divided by R1 plus R2. So under steady state condition, let me look at this current here. This will give you the crucial operating operation of this linear regulator. This current IRB, what is it equal to? On one end we have Vi, potential Vi at this end. Let me put it at Vi. Minus at this end, what is the potential? Here it is V0. V0 plus VBE. Minus V0 plus VBE. So VBE is nothing but this drop across transistor Q1, VBE1. So that's what I've used here. Now that divided by this value RB will give you the current through this. Now this current here, if you see, Vi is fixed value, constant, V0 is constant, VB is constant, RB is a fixed value. Therefore, IRB is approximately a constant value here. The only variation is due to variations in Vi because Vi is unregulated. So if IRB there is constant, this IRB divides into two parts. One part goes to Q1 as a base current, base drive, and another part goes down through Q2 as collector current of Q2. So let us say IRB equals, this is IC2. We'll call this one IC2, I of collector C2. Then this is IB1. Now, as IC2 increases, IB1 has to decrease because the sum has to be same as IRB, which is a constant. If IC2 decreases, then IRB has to increase so that the sum is the fixed value IRB. Now, this herein lies the regulation action. Another thing that you may have to note is, let us say you have the voltage across VCE of Q1, we'll call that VCE1, and as VCE, now we need to control VCE. So as IB1 increases, as the base drive to that is increased, more drive, it will go more towards saturation, VCE1 will decrease. So VCE1 decreases. And as IB1 decreases, you will see that the drive is lesser, as comes out of the saturation, moves more towards cutoff, VCE1 will increase. So this is our basic control or regulation action. The control action is like this. As V0 increases, here due to any reason, it could be change in R0, load resistance, or it could be change in Vi. You will see that this point, the tap off point A V0 will also increase. A is a constant. So if A V0 increases, the VBE of this one will increase because you are increasing this point and this point is fixed at VZ, reference voltage. So as this voltage increases, VBE increases, the drive increases, and therefore IC2 will increase. And therefore IC2 increases. If IC2 increases, you see that IRB is a constant current. If IC2 increases, IB1 has to reduce. So IB1 will reduce. If IB1 reduces, you see that VCE will increase, VCE will increase, and as VCE increases, in this loop, apply Kirchhoff's law, Vi is fixed. As VCE increases, V0 has to come down. Therefore, V0 comes down. So this is the regulation action, any increase, where the regulation action comes into picture and brings back V0 to the original value. If there is a decrease in V0, you will see that V0 will again increase and will be brought back to the original set value, and thereby the regulation action. So this is the operation of a series regulator.